Welcome back. Now, that challenge was admittedly quite a tricky one to score points on, as it requires more of an understanding of how the health crates actually function and interact with the player. So try not to worry too much if you felt as if you struggled. Before we take a look at how we could have implemented the audio, I'd just like to clarify to you, if you did successfully implement your audio, that the way I've done it isn't necessarily the correct way. There's potentially quite a few ways you could have actually done this. The main goal of all of this is to get you implementing by yourself, so if you prefer your methods to mine, then feel free to stick to them. But now let's take a look at how you could have completed this module's challenge. As always, we're going to start in FMOD. Now, you could have created two separate events for each audio file and then triggered them individually in Unity. However, just like how we implemented the two sounds for the teleporter object, we can use one single 3D event and control them both with parameters. So let's open up our interactables folder inside of our sound effects folder, and let's create a new 3D event that we're going to call Health Crate. Next, we're going to open up our audio bin and we're going to find our looping file that we are going to use at the start when our player first finds the crates. Now for this event, we're going to use two separate audio tracks. We're going to call the first one loop, and we're going to call the second one trigger. Now of course, because this is the loop track, we want to add a loop region, but we're going to set this region up a little bit differently to how we usually do them. Now just like with the teleporter event, we're going to use this region to hold our event cursor on our single instrument containing our audio. We'll then set the instrument to play asynchronously from the event, and we'll also resize the instrument so that it only lasts about a second or two. We'll also set the instrument to cut playback when the cursor is no longer interacting with it, as well as loop infinitely. Next, let's zoom in a bit to our event, and we're going to automate the volume of the loop track. So right click the volume dial, click add automation. So we're going to tell this track to fade out if the event cursor ever passes our loop region. We're then going to add the trigger parameter that we created in the parameter lesson, and then finally go back to the timeline, click on the loop region, and then we're going to set the trigger parameter as a condition of the loop region, adjusting the value to 0. So what all of this will do is play our instrument and loop it when the event starts. Now as you can see, whilst we hold the event cursor in a small section of the timeline using the loop region, the instrument is able to play and will loop the instrument cursor once it reaches the end. And because our trigger parameter is currently set to 0, our loop region is activated, meaning our event cursor stays where it is on top of the instrument, allowing it to play. It's also preventing the cursor from crossing over to where we set our volume automation, and thus fading out our track before we want it to. Now if we set the trigger parameter to 1, we hear the loop region fade out. So this means we can hook this parameter up to the moment when our player collects health to stop our loop from playing. It also means we can now use this trigger parameter to play our one-shot. Let's select our trigger parameter, and on the trigger track, on the value of 1, we're going to add a single instrument. Then we're going to search through our audio bin one more time, and we're going to drag in the key pickup health box open file into the instrument, just like that. I'm also going to turn mine down slightly to about -6 decibels, just so it's not too loud in the game. So now, if we play our event whilst our trigger is set to 0, and then switch it to 1, our loop fades out and we hear our one-shot. Now, if you feel like you can hear too much of your loop track whilst the one-shot plays, you can simply readjust your loop region and your asynchronous single instrument so that the loop region fades out quicker, giving room for the one-shot. Let's have another listen to that now. There we go, that's a bit better. So that's everything we need to do to our event for now. So let's assign it to the master bank. Let's then build our banks and then save our project so we can jump over to Unity. It's now time to look at how we're going to hook up our new event to the health boxes. First, we'll need a script. So make your way over to your FMOD scripts folder and then create yourself a new C# script. Now I'm going to call mine F_health crate. Once the script is compiled, we now need to attach it to the health crate. If you open up the level 01 gameplay object to have a look at all the child objects attached to it, you'll find two health crate objects. Now we're going to be interacting with the first health crate, which is this one here in our scene. And this will make it easier for testing and editing purposes. Now, if we take a look at the Inspector tab, when we select the health crate, we can see that the is trigger box on the collider component is ticked. We can also see a script already attached called interact on trigger, with a layer mask that's set to player. So just by looking at the object in Unity, we can work out that this object uses a trigger area to check for when the player has got close enough to the health crate. Now if we take a look at the box underneath the layer mask called on enter, we can see multiple different components being referenced, as well as functions, methods, and other commands being told to do something. We can then work out from this that this is how the health crate works. It first checks for an object assigned to the player layer that then enters the trigger area close to it. When the object enters, it's able to tell multiple different scripts attached to different objects to perform certain tasks. Now this box labelled on enter is what you'd call a Unity event. Now Unity events are a very powerful tool as they allow you to trigger multiple different functions from other scripts all at once. Those scripts could be attached to the same game object as the Unity event or completely different objects. Now if you're familiar with Unity events, you may have even used it yourself to trigger your event to play. But seeing as we'll be interacting with them more in the next module, in this video we're going to be triggering our event from our own script. However, knowing that these Unity events exist and are attached to this object will come in handy later on for us. Now that we've inspected our game object and learned a little bit about how it functions, let's get back to adding our script to it. Let's scroll down to the bottom and then we can drag our script to attach it to it. Once attached, let's right click it and let's click edit script. Once inside, the first thing we can do to save ourselves some time is add FMOD namespaces to our script. Now, as we learned about in our namespace lesson, this will save us from having to reference them every time we want to use something that was created within the FMOD scripts. So at the top of our script, we'll remove the two grayed out namespaces and we'll write using FMOD Unity as well as using fmod.studio. Now let's look at creating an instance for our event to play. Let's quickly create an event instance. And we'll call it HC, short for Health Crate. Remember that now we've included our namespaces, we no longer need to write fmod.studio before we create an event instance variable. Next, inside our start function, we want to assign which event we want to store inside the HC variable. We want to tell our code that we'll be playing a 3D event and that we need to play it from a specific location. Play our event, and then tell it to release the instance of our event once it's finished playing or has been told to stop. And with that, our event will now play our loop track once the game has started from the location of the first health crate. We can even save our script and test this by approaching the crate. Now as you can hear, our loop is playing, but if the player interacts with the crate, the loop continues and we don't hear our one-shot play. So to fix this, we'll want to add the onTriggerEnter function, which we'll use to trigger our one-shot when the player enters the trigger area surrounding the health crate. We'll also want to add a collider variable, if we haven't already, inside the parameter brackets, which we can call something like col or other for short. Now, whenever an object enters the trigger area, we'll be able to store a reference to its collider component inside of this variable, and then check information about the object that entered. Now, because we want to make sure that only the player object Ellen is able to activate this onTriggerEnter function, we can check for it using an if statement. So let's write if with two brackets, and then inside of the brackets, we'll need to compare the name of the object entering the area with the name of the object we're after, which is Ellen. So let's write the name of our collider variable, and then check that the game object has a name that matches Ellen. Then inside the body of the if statement, we'll tell our trigger parameter we created in our event to change if the object is called Ellen. Now to do that, we'll want to access our event instance variable and then use the command setParameter by name. Then inside this command, we'll want to tell it which parameter we want to change to what value we're setting it to, and whether or not we want to ignore the seek speed of the parameter. So inside the brackets, let's write in quotation marks the name of our parameter, which we know is trigger. Separating this argument from the next with a comma, let's then write the value we want to set our parameter to as a float, which will be 1. Finally, it doesn't really matter whether or not we ignore the seek speed option, but seeing as we didn't even use it, we'll just write true here. And so now, if an object called Ellen enters our trigger area, our parameter will change values from 0 to 1, fading our loop sound and triggering the one shot to play. And the last thing we do before we test this is include an onDestroy function. Now let's assume that the player never loses any health points whilst playing through this scene, and therefore never collects any health from our health crate. Well, the loop of the event will continue to play. And now in order for the event instance to be released, we need our event to stop at some point. Otherwise, we'll end up with a build-up of instances that aren't stopping. So when the player leaves this scene and therefore destroys all objects in this scene, including our health crate, we want to tell our event to stop playing so that the instance can be released. So all we need to write here is hc.stop. And then of course include the stop mode we'd like to use. Now because the player won't be near any health crates when they change scenes, I'm just going to tell my event to stop immediately. And now we can save our script and test our scene. Back inside of Unity, once the script is finished compiling, we can test our scene. So, if our player now enters the trigger area surrounding the health crate, we hear that our loop track fades out and the one shot plays. Perfect! Now it's time to look at the bonus criteria and set up a delay to change depending on the player's health before they interact with the crate. We'll need to start by adding a delay effect to the track that contains our one shot. So let's click on the trigger track. We'll come down to our effects chain and we'll click add effect. And we'll add the FMOD delay. Now before we do anything else, the first thing we want to do is make sure we don't hear any delay if the player interacts with the health crate at full health. So let's turn down the wet level, leaving only the dry signal to be played. Next we'll want to create a new parameter, one that we can change our delay levels with depending on the amount of health the player has. So we're going to click on the plus tab at the top and we're going to select new parameter. Now because the player's health can only be a whole number and not a decimal one, we'll want to set the parameter type from continuous to discrete, so that this will match the value of the player's health. We'll also want to set the min and max values in the range section from 1 to 5. Whilst technically the health can be set to 0 in our game too, this would cause the player to die and respawn, preventing them from collecting health. So there's no need for us to include it here. Next we'll want to set the initial value to 5, as this is the amount the player will start the game at. And then finally let's change the parameter name from parameter 1 to health. Now we can create our parameter. So we'll be using this new parameter to automate the wet level of our delay. So with our parameter selected, let's right click the wet level and let's select add automation. We can now set different wet levels of each individual health value. So feel free to select whichever values you'd like, but personally I'm going to leave 5 at minus infinity. I'm then going to set 4 to about minus 45, or as close as I can get to it. 3 will be minus 30. 2 will be about minus 20, 21. And then 1 will be minus 15. Now, if you've already completed this challenge and instead decided to automate a different dial on the delay effect, or even added a different effect altogether, then that's absolutely fine. The main point of this bonus criteria is to see if you can hook up a parameter to the player's health in Unity and get it to respond to you in the game. So what you choose to do with the parameter won't affect your score or jeopardize your extra 3 points. So moving on then, go ahead and build your banks by pressing F7 of course, and one more time, once that's finished, save your project. We can now look at how we're going to implement this parameter into Unity. Now as I mentioned to you when I first set you this challenge, the player's health is tracked inside of the damageable script attached to Ellen. So let's select the Ellen object and let's find the damageable script. Here we are. And then let's open it up like we would any other script by right-clicking and select Edit Script. Now that we're in the script, we'll want to find a way of measuring the player's health. Now we know that the health can only ever be a whole number between 0 and 5, so it's likely to be an integer variable. Now if we take a look at some of the variables declared in this script, we can instantly see two integer variables. The first one is called max hit points, and the second is called current hit points. Now, max hit points will likely set the highest value that the health can be at, whereas current hit points will hold whatever value the health is currently at whilst the player is in the game. So current hit points will be the variable we want to control our parameter with. Now, to discover this, you could have used a debug.log command to test these variables to see if and when they change values during runtime. But for now, I'm going to skip this step. Now that we know what variable we want to control our parameter with, we'll need to access it from our original script containing our event instance. Now, before we do that, it's worth us noting a couple of things about this script. First, the damageable class was created inside of the GameKit 3D namespace. So we'll need to remember that if we want to use anything from within inside the class. Let's also note that the current hit points variable is a public one, meaning we can access it from another script, such as our health crate script. Finally, also note that the current hit points variable is not a static one. So we'll not only need to reference this instance of the variable specifically, but we'll also need to reference the script instance and the game object it's attached to. Okay, so let's go back to our health crate script. So the first thing we'll do is declare a variable of the game object reference data type, and we're going to call it player. Now, there's two ways we can find the object we're after that we want to store inside this variable, which is the Ellen object. The first would be to make this variable public. By doing this, we can then interact with it within Unity's editor, select the Ellen game object, and drag it towards the variable. That will store a reference to the Ellen object. But the other way is to find the object we're after from within our script, and that's what I'll be doing in this video. So because of that, I don't need my variable to be a public one, so I'm going to make it private. So on the first frame of this scene, we'll want to find the Ellen object. So we're going to set the variable we just created to be equal to the game object that we find that's called Ellen. And now we have access to the Ellen game object via our player variable. Now, of course, don't forget that we are able to use the find command because we know that there's only one game object in our scene called Ellen. So now that we have access to the game object, we now need access to the instance of the damageable script that's attached to it. So at the top of our script, let's create another variable. This time it's going to be of the damageable reference type, and we're going to call it D for short. Again, this is going to be a private variable. Now currently, our script doesn't recognize our reference data type as it can't find a class called damageable. The reason why is because it was declared inside of the GameKit 3D namespace we saw earlier that we're currently not using. So all we need to do is at the top of our script, outside of our class, we need to say that we are using the GameKit 3D namespace. And now the data type is recognized by its green color. Now all we need to do is get the actual damageable component attached to Ellen and store a reference to it inside of our D variable. So in our start function, we're going to set D to player.getComponent damageable. And now using the D variable, we can access all of the public variables inside the damageable script. So now let's turn our attention back to the onTriggerEnter function. Now the first edit we need to make here is to our if statement. Now that we have a reference to the Ellen game object, we can use our variable instead of searching for it by name. So let's remove this part of the if statement and instead check to see if the object that enters the area matches the object referenced inside of the player variable. Let's now look at changing the value of our parameter once the player enters the area. So inside the if statement, before we trigger our one shot to play, we'll write again hc.setParameter by name. The reason why we've put it before is that we want to make sure we set the value of our delay effect before we actually trigger the one shot to play. This time we want to set the value of our health parameter to match whatever value the current health points variable is at. So let's put the name of the variable containing a reference to our damageable script and then the name current hit points. Finally, all we need to do is tell this command to ignore whatever value our seek speed is set to, and we're good to go. Let's then save our script and test it one more time in Unity. Before we actually play the scene, however, there's one last change we need to make to the health crate. Now earlier I mentioned how the Unity event that's part of the interact on trigger script performs multiple functions when the player enters the trigger area surrounding the crate. Well, one of those functions it performs is actually located inside the damageable script attached to Ellen, and it's called reset damage, as you can see there. Now, as you can probably guess from its name, this will reset the damage that the player has taken by bringing their health back up to 5. Now, currently, our script is underneath this script and its Unity event, as you can see here. This means that whenever the player interacts with the crate and enters the trigger area, their health will be set to 5 first, and then our script will check the player's current health for our parameter. And because the health has now been set back to 5, our set parameter by name command that we just wrote in our script will retrieve the value from the current hit points variable as 5, and thus we won't hear our delay. Luckily for us, however, there's an easy fix to this. Now, just like how in our scripts, each individual line of code is performed from top to bottom, each script attached to a game object is also performed in the same way, from top to bottom. So all we need to do is drag our health crate script above the interact on trigger script, just like that. So now whenever the player interacts with the crate, our parameters will be set to match the player's health before it's reset back to 5. And with that, we can finally test our scene. So now that I'm in the scene and I've taken some damage, let's see what happens if I try to collect some health. I can hear the one-shot play and I hear that long delay that follows. Now, like I mentioned earlier, there are multiple ways you could have set all of this up. Another way, for example, would have been to write our set parameter by name commands inside of a custom function. And then from there, you could have used the Unity event on enter to trigger it. Of course, you'd have to again make sure that your function is triggered before the damage reset function to ensure that the delay is heard. But with that now done, our bonus criteria is complete. So like I mentioned earlier, you could have altered the delay in any way you'd like. The way to score those 3 extra points was to set the change to happen based on the player's health and then get the change inside the game. So long as the one shot sounded different at each health value, you can give yourself those points. But how well did you do overall? Did you collect the main 5 points, or did you struggle with them slightly? If you did, then don't worry too much. This challenge really does throw you in the deep end, as there are quite a few elements that you needed to figure out on your own with some trial and error, and it did require a little bit more understanding of Unity and FMOD. Hopefully either way you have scored an amount you're happy with, and you're now ready to check out the final module of this course.